Yeah, it's so good to see everyone here. It's great to be at DDD, and yeah, great to see a lot of faces. Some are familiar, some new faces, but yeah, it's great to be back in the ecosystem again, and yeah, seeing every one of you. So, I'm Renaldi, and today I'll be doing a bit of a talk on Safety First app, which is basically just talking about 12 product patterns that turn failures into recoveries, and it's really more on kind of like a lessons learned kind of thing, essentially. And it's just really more kind of like how to pretty much just apply the right patterns so that you can essentially just make sure that you're applying this good practice for your users and pretty much avoid headaches like later on. So, a bit about myself. I'm Renaldi, and yeah, pretty much just a few, I suppose, like fun facts about myself. Like, currently hold 20 certifications for Microsoft Azure, 14 for AWS, and also am an AWS community builder and Microsoft trainer. I'm also an instructor and author. I've also wrote the Azure AI Engineer Associate Study Guide. Actually, I'll be giving away some copy sets as well at the end of the talk, so do stay tuned for that. And yeah, pretty much also international speaker as well. Have spoken at over 50 events and conferences internationally. Have been an organizer as well of the Melbourne Python meetup. And yeah, in general, I enjoy all things AWS, open source, generative AI, and virtual reality. So today we're going to be going through agenda first, and why firstly we're going to talk about why safety first is a product capability. And after that, we're going into the 12 recovery patterns that you have as part of this, and what are the examples and what are the trade-offs that you would get from this essentially. And then we look at having more system-aware design through retries, receipts, degradation, and rescue mode. And then we're going to be looking a bit more into kind of how you would be able to apply that as well in kind of like customer-facing runbooks and comms, and also eventually getting a bit of a worksheet to be able to kind of like audit one feature in a sprint, which I'll invite you to pretty much try to take a look at and try to apply it so that you can bring the learning that you get from here into your day-to-day, which is essentially what we're all here for, right? We're here to basically get better practices so that we can essentially apply them to whether it be like our own personal lives or professional career, essentially. So that's essentially what it's going to be about. And after that, we'll go into Q&A. So most apps are always built for a sunny day. We always build apps focusing on the features and ensuring that the features actually work as they should. However, oftentimes users, our customers, live in a messy middle. We have users mistype, misclick, and change their mind mid-flow. It's a very common thing. Customers aren't perfect. We'll always be able to see that one edge case that customers do, or just have that one random day where, for instance, like, say like a AWS region goes down, and yeah, we've all been through that. So yeah, networks wobble, services timeout, and retries happen. It's a common thing. And really, what we want then to be able to do is just to be able to apply those safety patterns to turn what you would have as panic into progress. And the goal really is to be having fewer tickets, fewer pages, and fewer calmer users. And rainy day failure modes are really normal. We need to be able to design for these as first-class states. So we need to ensure things, for instance, like double clicks and repeated taps under pressure actually do get registered properly. Stuff like refreshing, back button, tab close, session expiry. I mean, I'm pretty sure some of you can relate here too, but like it's a very common thing to pretty much click the back button on a page on some of your favorite, I would say, kind of like user interfaces, and then just suddenly get the notification, unfortunately, the back button isn't supported, so you have to like go back and get thrown to the home page again. It's a very common thing. And that's why we have to always think about these kinds of things. There is also pretty much the possibility as well of like potential latency spikes, partial responses, 429s, and 5xxs. And mobile background and offline transitions are also part of these as well. So what we need to do is that we need to create a shared language for safety so that product design and engineering can be able to align on recovery. Having reversible actions instead of irreversible mistakes is the start of it. ensuring that users can actually reverse on what they did instead of then having actions that are permanent and can't be modified again, because we're human. We make mistakes. And we can't always expect everyone to pretty much get things pretty much like right in the first go as well. Having durable intent that survives retries and refresh, ensuring that what we do put forward is able to survive relevant retries or refreshes that we actually do. Having explainable failures with an obvious next step. As engineers, oftentimes we think that our customers, our clients, has the same way of thinking as us. Like, for instance, like when they encounter like a 400 or 500, like oftentimes users don't know what that is. And well, we need to be able to essentially make it as explainable as possible, at least for the relevant target audience. And having a safe resumption from a checkpoint with one click, that one autosave that you have essentially from what a form you're currently working on really means a lot to users than being thrown out of the page and then basically just saying that you need to restart from all over again. So what are the 12 patterns? Here's a field guide. The field guide for turning failures into recoveries. Firstly, it's going to be on the user-facing recovery side. Number one, undo everywhere. And I'm going to be going through these one by one later on, but for now, I'm just going to be walking through each one of these first. So number two, autosave and drafts. Number three, guard destructive actions. Number four, resilient forms. Number five, explainable errors. Number six, one-click recovery links. And then we go into the system-aware resilience side, where we then look more into kind of like what we can do in terms of the backend side of things. Number seven, degraded states. Number eight, idempotent actions. Number nine, long-running scripts. Number 10, receipts. Number 10, outbox and offline queue. Number 11, rescue mode. And number 12, customer runbooks. So let's jump straight into the first one. Number one, undo everywhere. We need to make accidental actions cheap to fix. So having a default to and undo instead of blocking confirmations. So ensure that we can essentially undo actions that we have originally put forward. We can't always assume, as I mentioned before, that users will always get things right the first time around. We need to assume that there's always that potential of users not getting it right the first time around and needing to potentially like undo and edit it with something else. We need to be able to keep undo available long enough to cover distraction and potential latency. It's a very common thing to be distracted essentially and or essentially have latency that pretty much might be present that will only allow them to see that undo button for a very short period of time before they actually then lose the capability of undoing. If you've already seen a lot of interfaces, you've probably also seen that some of them pretty much also have that particular undo button as well, and then they have a bit of a loading duration as well, in which kind of like they have that specific duration that you can undo before it's completely permanent. And this kind of reasoning and assumption pretty much is very quite, I feel like common as well, pretty much to take into account. It's a very common thing to pretty much ensure that you are at least giving your customers the right amount of time before it pretty much just completely permanently applying it. And make undo server backed when the action also have side effects as well. Ensure that you also instrumenting specific undo rate as well to find confusing UI. And yeah, pretty much one great example that I have seen recently is with the recent usage of AI as well. One great thing that I've seen with a lot of tools that are pretty much like, for instance, like using AI or pretty much like are relevant to kind of like AI chatbots or AI tools, it's like you pretty much just are able to still like kind of like undo to like the previous checkpoint and undo basically like what AI might have created essentially. Maybe like it created like some AI slop, like we don't know. And basically you can still pretty much like revert to the previous checkpoint. So these are just some examples. So from very simple stuff, like you can see basically from the code sketch in the right, it's basically just showing, for instance, like you have a specific intent ID as UID, then pretty much like you look towards like being able to use the API to remove the specific item basically based on the ID, and then pretty much you would just be able to then have a specific toast that pops up and basically just like allows to be able to undo it and restore a specific item. So very simple stuff started from that. And yeah, pretty much as you can see, some examples as well is also like Gmail undo send, Slack message deletes, for instance, like Trello cart moves. Like these are all just examples of this. And of course, like the trade-off for this is that you would require storage essentially or compensating actions as part of that. Number 2, autosave and draft states. You need to treat save as infrastructure. Persisting drafts on every meaningful change is very important. Ensuring that you're able to have that particular reassurance to the user that, okay, if I, for instance, just get up right now because essentially like my kid called me over, or essentially like I'm just feeling for a cup of coffee, when I get back, it's not going to just completely just kick me out and just start over from like the beginning again. It's a very meaningful change basically for the user. And especially when they have to fill in a very long form, which oftentimes I also have a bit of a, I would say kind of like a pet peeve for as well. It's kind of like, you know, like you fill in a long form and suddenly you get kicked out essentially because you didn't fill it fast enough. So it's a very common thing. And you need to ensure that you expose essentially like statuses like draft, saving, saved as explicit UI states, because that gives users reassurance that you are essentially putting through the right things and that you are essentially successfully saving it. And you need to be able to resume the drafts as well after refresh, navigation, off expiry. So these kind of strategies need to be thought out as well in advance too. Like how do you get the user from when they first start off from creating basically the form to then continuing on it? Do you look at basically asking them to kind of like go to like a specific like link that you send them through email? It's like just a simple kind of like, oh, we've saved your draft, so you just have to go through this link basically, or enter this specific code to resume your session. Or you could pretty much just also just have it like autosave as well, kind of like a Google Forms thing as well. So it really depends on your approach for it. And of course you need to design for conflicts, and last right wins is, after all, quite rarely humane. And some examples of this, Google Docs does a good job of this, Notion does a good job of this, Figma drafts, if you work with Figma, and pretty much it's able to like autosave. And of course, conflicts come as part of this. You need to be able to ensure that and consider as well that the conflicts need a policy that users can understand. How do you resolve conflicts? It's basically something that you need to think in advance, like can you pretty much resolve conflicts essentially in terms of kind of like asking the program to basically solve it, or do you let the user decide what version they want to have? So think of it as kind of like, for instance, like GitHub merge conflicts. It's kind of like you need to think about like how they are able to like resolve these kinds of actions. Number 3, guard destructive actions. Add friction only when the blast radius is high. So it's a very common thing when you look at these specific actions and you look at these specific destructive actions, essentially when you pretty much place deletes, someone essentially deletes something accidentally and then they can't get it back again. It's a very normal thing. And that's why you need to be able to prefer essentially reversible deletes with a retention window. Think of essentially a lot of the ones that you've encountered before, like Gmail, for instance, or GitHub repo deletion. Like, for instance, GitHub repo deletion, or like when you delete like AWS resources on AWS, you essentially need to be able to type down the name of the resource. And that essentially prevents like potential unfortunate deletions that should not have happened. And you can also use that confirmation as well to prove intent, not like just an "are you sure?" essentially. Like are you just going to delete this? Because sometimes like even if you ask like "are you sure?" or "do you confirm?" it's like it's a bit vague sometimes, and yeah, customers sometimes might be distracted, they're not sure, and that's why oftentimes like more, I say, robust and more sure kinds of setups like typing the specific resource name really does a lot. And of course, you also need to show the consequence as well in plain language before the action itself as well. and make recovery visible as well in terms of restoring, undoing, or do you have to go through a support path? You need to show what they can do essentially to be able to undo this. Because oftentimes users don't just know what to do, and that's something that to keep into consideration. And the trade-off of this, of course, is that friction can reduce conversions on low-risk actions. So we also need to find that good balance as well. And this is just an example, essentially, at the sketch as well. It's like, for instance, like, yeah, if type basically is not equal to expected, then you would throw basically a new error that confirms basically a text mismatch. And accordingly, when you look at delete a specific project, essentially, it would just basically like show as well, like delete it and to say like restore available for 30 days. So you're clearly saying how that it can be restored and the duration that can be restored for. Just so in case that they do come back and say, oh, okay, I shouldn't have deleted that, they can come back to it. Number 4, resilient forms. You should never lose input. Keep the form state local first. It's something that I always also like to say as well. Like you need to think about having sync as well as a separate concern. Because oftentimes you can just store it like locally first, and yeah, pretty much essentially that would already help you in terms of a storage perspective, but at the same time also pretty much help you in terms of just ensuring that the user has it locally first. And validate inline and early, close to the field. Having the retry submit essentially being done without specific clearing inputs or jumping scrolls. Another very common problem that users often have is pretty much when they pretty much try to retry a particular like submit essentially, oftentimes there is small caveats that come from that, and yeah, pretty much it sometimes like clears the inputs first before they actually can try to like retry with the same fields again. So these are pretty much like some key considerations from that. And persist partial progress as well without especially for like longer forms or wizards, as mentioned before too. So Sketch is basically one example as well, just kind of like a use effect hook. You pretty much would just kind of like, for instance, like set the item in like local storage, stringify it, pretty much just set the relevant status as well, and like the specific submit as well. And pretty much when it's at that status, then it pretty much would just await based on the what it's currently doing, and then after that, then you submit, and if there's an issue, they would catch it and basically just kind of like do a fix and retry basically as part of a separate status. So you would essentially look at also having a bit of a trade-off as well in terms of handling specific stale drafts and validation errors as well as part of this. And some examples of that could be like checkout flows, for instance, that keeps like fields after a payment failure. Payment failures pretty much, for instance, like always happen in two different kinds. It's always, from what I've seen, it's always either you see it, you fail, and then like they wipe out like your credit card field and everything else that goes with it, which is pretty much like a headache for a lot of users, or they just wipe out like the credit card field. And oftentimes people, of course, prefer like the latter than the former. So it's a key consideration. Number 5, explainable errors. You need to make the next step obvious. You need to say what failed in a specific user language, not the system language. Because if you're a customer essentially and not a developer, pretty much like you don't understand basically like terminologies. No one will understand what's a 500 error or a 400 error or a 403. No one knows that. And that's why we should be making it easy for our users to understand what actually is the problem. We need to say what failed in the user language. For instance, some examples like payment decline, try a different card, or contact your bank is a much more robust error message than saying error like 500, because they don't know what it is. What's a 500? And next thing you know, they'll be retrying and not getting anywhere with that. You need to be able to offer the next best action. Should you retry? Should you try editing it again? Or should you contact support? You need to think about what to best do to be able to work for this. And include a correlation ID as well for having the relevant support and also the relevant incident triage in case this particular error needs to be investigated further, and so you can refer to it easily. Avoid blame and mystery as well. no specific no codes or like no specific like unexpected error essentially, because that keeps things, well, very mysterious, but it's only you who gets it. No one else will. And you need to pretty much also, consider as well the trade-offs of requiring good error taxonomy and mapping as part of this, ensuring that you are mapping the right errors and the right messages with the right error codes, so that you also know pretty much from robust documentation, not only from a user perspective, but if a new dev steps in and they look at your code, you can pretty much just look at, okay, this is probably the problem. So an example of this could be showing error, title pretty much could not save changes, and detail basically just showing like, the server timed out, your draft is safe. That gives that amount of reassurance to the user at least as well. So although it's timed out, but clearly you're showing that it's saved. It's not the user going, oh no, it's like, as my draft saved, do I need to do it all over again? You get that good reassurance to them. And from there as well, you can pretty much then show some specific actions as well, for instance, like retry. And that pretty much would be able to help you also capture the correlation ID as well, as you can see over there too, since that pretty much would be then used for you to debug any particular issues that you do need to look into. One-click recovery links. Resume beats restart. So create stable links as well to a safe checkpoint. Oftentimes, it's a very common thing as well where you pretty much are not able to resume once you've already created a particular it's in essentially. So for instance, like let's say like in a checkout kind of like cart, for instance, you see from the code as well, it's like basically having a relevant like await as well for the relevant receipt. You basically start the flow from the cart ID. You basically then push it up the specific checkout / resume resumes and like plus the receipt ID, and then you pretty much would be able to have the resume page fetched based on that specific like receipt ID. And that pretty much would be much easier rather than having to start all over again, basically. And having the state rehydrate as well from the server and not the fragile client memory really does a lot of good for this. So keeping these kinds of design patterns in consideration really does a lot for ensuring the user experience. And having that clear resume language as well instead of start over, as we see as well from this example. And of course, putting the recovery as the default when a flow would fail midway, since users would feel much more reassured in that sense. And the trade-off, of course, for this would be requiring stable IDs and also having durable server states. Now let's go into system-aware product design, more on like the system side, the back-end side, compared to like the front-end side. So you need to ensure that although the back-end is degraded, your UI still has choices of what to do if that is the case. So degraded states is basically one example, as mentioned before. So you need to show what works. Expose the partial degradation instead of a blank spinner. So you've probably already gone as well to like a state as well on the website where it's just basically showing, for instance, like a 404, or basically just showing page not found if like something basically is currently happening to the site. And basically, or basically sometimes like you just go to the site and like you just see, you just try to drag something and suddenly it doesn't work. So these are very common things basically that you encounter like when you like work with these kinds of systems. And that's why you need to expose that partial degradation. You need to be able to ensure that users also see what's happening, but you also show that if degradation does happen, you degrade optional features first. You keep the core path alive. You essentially use banners, for instance, to explain the impact and what is the expected duration of a specific degradation and what options do they have. And you can also try to also have a bit of a lean on cache data with staleness labels as well when needed too. So what is the latest refresh? What state is it currently at? And how do you look at getting out of that? And what options do you have at that degraded state? So that's essentially key things that you need to consider. So part of the sketch as well, as you can see over there, it's basically just showing, for instance, like if the status for payments, for instance, is down, then you look at degrading pay. And then pretty much from there, a banner is shown, payments are degraded. You can still browse and save carts. So you clearly are showing what can be done instead of kind of like leaving it a bit of in a user kind of like, oh, can I do that? Can I not do that kind of situation? So it's quite important. But of course, as part of that, you need to be able to consider that you need trade-off consistency, because you need to be able to label the stale data clearly. You need to label what is stale and what essentially might not be, and what is essentially still consistent with what you would expect. And idempotent actions is the next one. So idempotency is a very important key consideration in a lot of systems, especially when you're looking at more kind of like robust, or for instance, like financial systems. Well, in general, it's very important, and it's from a data consistency perspective. So retrying should never do like a double charge. Like, for instance, like one very common thing is like, I'm pretty sure that some of us here are a bit scared as well when you tap that like pay button on a page twice if something pays, like if it fails, for instance, like the first time, because you're afraid of basically being charged twice. And that's why some interfaces also say as well, like, please do not try to like retry like and tap the pay button again, because you might be charged twice. Like, we should be instead looking to prevent this in the first place. And one thing of doing this, for instance, is that's why idempotent actions is very important. We need to generate, for instance, like an idempotency key per user intent, not per request. Reusing the same key across retries, refresh, and back and forward, returning the same result for the same key even after timeouts, and also showing a receipt as well so that users can also verify what has happened. And an example is that sketch. So, for instance, we get or create a specific key as a checkout, and then pretty much we await for like the API charge to go through, and basically the key then returns the stored result, and we would then essentially return the same receipt that we would expect. And the trade-off of that, however, is that we would need the keys to have storage and as the expiry strategy. So that's another key consideration that we need to put. But if that means a better user experience and lesser complaints, then yeah, it's better time saved, I think. Especially when you consider that if you double charge someone, for instance, then yeah, just have to kind of like work through the whole refund process again. And for instance, Stripe does a good example of how like having like idempotency keys, like safe pay again buttons, essentially. Number 9, long-running work with receipts. Progress that survives refresh. So oftentimes, you have really long-running work. Sometimes it happens in the background, and sometimes there's just no status at all. You just have to wait and hope that you're getting somewhere. And sometimes you don't know like what's happening in the background. You don't know what's happening, and that's why it's very important, pretty much, to have like relevant receipts. So start work, for instance, that returns a receipt ID immediately, so that you know that it started. And having the progress queryable and reviewable across sessions really does mean a lot. So being able to set those particular like checkpoints, or at least like show that particular progress, really means a lot to users, and also for you as well, of course, for debugging purposes, if you do need that. And users themselves can also close the tab as well without losing the outcome, because oftentimes, whenever there's a long-running process currently happening in the background, users are always scared to close the tabs or basically close the browser in general, because yeah, they don't know what will happen. Do they have to restart all over again? Which is a very common problem with a lot of sites in general. And so we should be making it easy for our users to be able to work with this. And of course, having receipts double as audit logs during incidents really does a lot of good as well to be able to debug it easier too. And as part of this, you can also see as well from the code sketch as well, we basically, for instance, would do like an await based on like a start export, for instance. When we start exporting, we basically then push the relevant export route, and then we pretty much like would just like be able to poll the page as well based on specific like ID status. And accordingly, we would then provide like basically considered trade-offs as well, which basically we would require background workers and status APIs as part of that too. And some examples of this could be in terms of like report generation, uploads, exports, and model runs that could be possible as well. Number 10, outbox and offline queue. So we need to keep treating network as well as possibly intermittent. Capture the intent locally, then synchronize when the network cooperates. We need to ensure that we have this good balance as well. Like what actions can capture locally and what actions can we actually synchronize accordingly. Like, consider things, for instance, like an email send queue. it means a lot to users who pretty much are currently sending it, and pretty much at least that they send it locally, and then pretty much when it gets online, then they can pretty much just get it like sent through. Having notes are synchronized as well, having like offline first like mobile apps, these are all very important considerations. So as you can see, for instance, like you would queue it in an outbox, you would basically then accordingly synchronize the loop, you would show basically the UI, you have 3 changes queued, and you clearly show that these are queued. You're not leaving it like up to a chance essentially. And then you would also process it idempotently. And you would show like, for instance, like what's queued, what's synchronizing, what's failed. You would allow users as well to cancel or edit the queued actions, and also reconcile the conflicts as well, deterministically and transparently. 11, header rescue mode. Make the product safer during incidents. Use feature flags as well to disable risky paths without redeploying. Switch to read-only modes as well when you have writes as well that are able to threaten integrity. You need to block destructive actions first, and then you keep viewing and exporting accordingly. And you need to be able to explain as well what's disabled and where users can essentially verify what outcomes is put through. So for instance, look at the code sketch first over there, and you would have essentially a rescue mode flag, and pretty much based on that, disable all writes basically if the flag essentially in rescue mode, and accordingly you would show a specific banner as well, like this in rescue mode, changes are paused to protect your data. It shows that you are considering this for your user, so, and at the same time, it's not letting them put in data that you would pretty much are going to like override or like not save anyway. So it does a lot of good during incidents especially, so that at least like users are not losing their data, and they don't have to repeat specific actions and file a ticket as well to you too. So the trade-off of that, however, is that you would pretty much need it to be pre-wired and rehearsed in advance as well. So it needs a bit more of like strategy planning for that. Last but not least, the 12th pattern, customer-facing runbooks. Make support effective at 2 a.m. So let's maybe do a quick of a, I know I've been talking a while, so let's do a quick of an exercise. Like who here actually has already been like on call? I assume, okay, quite a good amount of the room. Then you know the pain of sometimes having to wake up at like 2 or 3 a.m. And oftentimes, the hardest on-call times for us always is when you receive a particular message that basically just says, okay, an error has occurred, or okay, this, like, I can't access this site, like, this site is down, and then you don't get any further logs. And then you have to ring up someone else from your team. It's like, oh, can you provide me further details on this? Because I don't have access to, like, this part of the site, basically. Or I don't have access to, like, this database, and I can't troubleshoot further from there. That's the worst thing you can have at, like, 2 a.m. And that's why we need to design things to work easily for us, as well as for users as well. So have them be able to provide a consistent incident message that users can share instead of, say, like a 500. Because if users basically, like, say like you basically like work in an enterprise, or if you work basically on a really, really big project, and then basically like user says like, oh, I'm getting a 500, and it's like, where? How? Like, what are you trying to debug? Like, that's the problem. And that's why as well, it's very important to think about this in advance and expose relevant correlation IDs, receipts, and known issue links. Think about documenting the safe user steps as well, verifying, retrying, waiting, and aligning as well the UX with your operational playbook. So think about, for instance, like an incident quick guide. Think about like what's impacted, what still works, how users can verify receipts, when to try safely, and support escalation path. So having a specific customer-facing runbook really can mean a lot to customers who pretty much know the steps you need to take, but at the same time for you, who pretty much will be waking up at 2 a.m. to 3 a.m., dealing with that with a brain basically that is currently needing coffee. It's a very important thing pretty much to keep in like consideration. And of course, the trade-off of that is like you need to continually update your runbooks to be able to ensure that they stay current and accessible. So how do you choose the right safety tool? The preference really is in terms of like reversibility, then durability, then friction. ask yourself questions like, can we make it reversible instead of confirmable? What is the blast radius if this goes wrong? Is retry safe, or can it duplicate side effects? Do users have a stable place to resume and verify? Can support diagnose this without engineering? And of course, one of my personal favorites right now is like, are you putting enough safety in AI tools? And I say this because a lot of enterprises a lot of companies these days are putting a lot of pretty much effort in terms of like AI-based coding, and that essentially widens the area much more essentially as developers, because we need to ensure that we are putting as well like the right safety within like the relevant like AI tools, and actually double checking that they are doing the right things. And that's why essentially it becomes an even bigger importance for us to be able to double check that. So a bit of a mini case study, a bit of a checkout flow essentially of what like implementation that I have as well like done as well for an organization before. So basically, think about this: you have the same backend, you have different product outcomes. Before, it was in a state basically where the product basically was, you needed basically to remove, when you remove the item, you require like a bit of a confirmation model. You would have the form clear as well after a payment failure. The timeout basically would force a start over. Retry would be able to like double charge, and more complaints received. So this essentially was a state of basically like one of the products that essentially like I've worked at originally kind of like came to me for. But essentially after working on it, essentially after applying some of the patterns that was mentioned before, you then bring it to a different state, which basically you would have undo and remove item. You would have autosave like draft checkout details. You would have the receipt page basically survive the refresh. You would have the idempotent pay to be able to prevent like complaints essentially in the first place of like, for instance, like people retrying it and getting like a duplicate issues, and pretty much more user satisfaction. And what I want to pretty much also leave you with is this audit worksheet. So pretty much you would have it on like this worksheet essentially to, and I encourage you to pretty much like take a screenshot actually of this slide and try to audit one high impact workflow that you have. So I'm not going to go through every one of these questions, but I just want to highlight you to pretty much take into consideration, ask yourself questions like, what is the most common accidental action, and can you undo it? And are you able to run the rainy day tests for this flow? And pretty much just try to use this on one feature. Try to finish this in a single sprint and see the improvement that can bring to you. And then after that, try to apply this in more flows. And pretty much from there, you can pretty much build on the pattern and apply better patterns for your users that way too. And think about how you're going to ship this in a single sprint. Pick one flow with a high ticket volume and revenue risk, add receipts and save retries first, layer and undo drafts, and pretty much instrument through the undo rate, error rate, abandon rate, and write the support runbook as you build, as it exposes gaps fast. And what do you measure? You would look at things essentially in terms of KPIs like undo usage and reversal success rate, autosave success rate and draft resume rate, retry success rate, time to recover, and also support tickets per 1,000 sessions for a target flow. So think about it in terms of safety as a feature. Featured fewer tickets, fewer late night pages, users will feel looked after, and really just pick one flow this week and apply the worksheet. And as I mentioned before, I was gonna plug essentially a book that I worked on as well. So essentially, basically, if you're kind of like working on like AI flows as well, this also has some best practice, which I mentioned earlier too. So yeah, pretty much some of the practice I also kind of like picked off from some of the stuff that I do work here as well. And as I mentioned, I'm reaching the end of my talk, but actually I would like to also open the floor for questions. But at the same time, I think we do still have questions here with time. And yeah, pretty much. I'm going to be also like giving the first 3 people who ask questions, yeah, basically a copy of like the book as well, essentially. So yeah, pretty much happy to open the questions.
So in, I think number 1, you had undo everywhere, and there was intent ID. What's the value in capturing intent ID?
The intent ID really is more towards being able to put through essentially like what you're like basically like what you're currently trying to like undo essentially. So it's more kind of like really trying to capture basically like what you are trying to reverse basically just for like further like debugging purpose essentially. So it's more kind of like for you to be able to see like where basically users are kind of like currently trying to like undo basically, and kind of like also to like cross-reference as well like if users have any issues later on too.
Thanks for the talk, really insightful. I was wondering, in real world, in your experience, when you think about applying these principles and when they start to sort of blow up the scope or affect the timelines, how do you approach that when talking to the wider stakeholders?
I feel that we definitely need to think of it in terms of metrics. And that's why I was mentioning before in this slide as well of kind of like what specific metrics would we need to measure to be able to at least convince, because these are not only for us internally, this is also going to be for when we try to convince stakeholders. It's like, how are we basically doing in terms of getting like specific like tickets that we need to resolve? Like, are we blowing up? Like, how much like issues that we have like on call and dealing with like issues basically. So I suppose like it's really metrics like this that really do a lot of good when we do present them to stakeholders, and it also supports a lot of the building the business case as well, because after all, it also depends on a stakeholder too. If you're like, for instance, like talking to like a higher level, it's more kind of like, for instance, like presenting like some potential like financial savings as well that you could get from this. So it's really, I think, in terms of you need to be able to implement, I think, like a proper what is it state before, what's the state after, and kind of like present basically like the successes that you would get from it as well. But if it's kind of like before too, it's kind of like presenting basically like the after case as well, basically like what this would solve, and basically pitching it that way in terms of like how this would get us to a better place as well in terms of like the metrics.
I would think at the very least have the conversation, at least talk about these things. And if you look at it and say that, no, we're not going to do that right now, then at least you've talked about it and done it. But Cariad, you have one. Did you have a person with a question?
Right here. Is
Yeah,
this all right?
yeah.
Here we go.
Hi, do you have a specific incident or success story from applying one of these in a business, either from a user perspective or a business perspective? Just something that maybe stands out to you?
Did you say success rate, sorry?
Success story.
Success story? Oh, yeah. The case that I mentioned earlier actually was one particular one, since, like I mentioned before, essentially, the checkout flow kind of like case, essentially just keeping things a bit like vague, basically for like NDA purposes as well, but like basically kind of like working on a success flow, essentially, a checkout flow, and pretty much we got like a lot of essentially like kind of like basically like complaints, basically, for instance, like support tickets on like duplicate charges, and pretty much also kind of like getting more kind of like complaints as well in terms of like basically like how they were finding it a bit kind of like finicky basically on the side of kind of like being able to like basically like have to like fill in the form like all over again kind of thing. So it's kind of like one of those like legacy forms essentially that you would see. And yeah, pretty much it's kind of like revamping that and applying some of these patterns, including like applying idempotency and pretty much just kind of like having that more like auto-saving and pretty much like and kind of like the need to be able to kind of like provide consistent feedback essentially when you kind of like fill in the form. It really meant a lot for users, and because of that, I think quite a number of the I would suppose kind of like the error rates and also kind of like the amount of like complaint tickets that we got that we had to resolve manually pretty much really went down. And yeah, pretty much, so I would say like that's definitely like one of the success stories that I can share.